Now, going into topic 6 of Unit 3, we're going to look at the conditional and circuits. Now, as we did in the previous lesson, we're going to have you include in your notes the truth table for the conditional. So get ready, we'll do this together. So looking at what we have here, in the conditional, we think of if, then in a compounded statement. And the if part is the antecedent, and we list that as P. The arrow is used for the statement then, and what follows is the consequent, and we represent that by Q. So as we fill in the conditional truth table, here we're going to say true, 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 false, false, true, and then false, false. So this is the general way we've set up the truth tables in the past for the and, the caret, the or, the inverted caret, but now this is for the conditional. Now, if both are true, this is true. Now, if the antecedent is true, but the consequent is false, in the conditional, this is false. Now, if the antecedent is false, but the consequent is true, this is true. And this is kind of an interesting part. If they are both false, the antecedent and the consequent is false, then it's true. So in summary, the only time the conditional is false is when the consequent is false. Okay, back to our regular lesson now. Now, in our first example, here is our statement. If you can afford it if you see it on television. And you want to put this in an if-then format where the if-then is the connective. So notice we can pick it out. If you see it on television, the if is there, then you can afford it. So the connective if-then, and they say you can rearrange the wording, and in some cases may even add a word or two. Now, for example 2, the basic statement is no person in the United States. So no person negates the person. So someone in the United States, and they've negated this, not in North America, then becomes is in North America. Now, we're not asked to define the validity of this statement. We're just asked to put this statement in this form. And, you know, what's that old expression, if at first you don't succeed? If you are doing this in your homework and you don't get it right, then, you know, you get another shot at it to get it correct. Now, keep in mind that if someone's in the United States, they may not be in North America because we have Hawaii. Hawaii's not in North America, while Alaska may be considered North America, that part of the continent. All right, see what you come up with. Now, as you read these, again, some of these are arguable, and I think I would pick C for this. And again, you'll see what the homework is looking for and can tweak it one way or another. Now in example 3, and again, you're putting this in your homework log, we're looking to see if these statements, because of the arrow here, this is in the conditional, is going to be true or false. So you determine the validity of this. Now, 4 squared is equal to 4. That would be the true statement, but they're saying that's not true. While it is true, not true, then this part is false. False, then. Now, 3 plus 3 is equal to 6. That's true. So in the conditional, false, then true. Now look at your truth table. Is this true or false? Well, it's true, because the only time in the conditional where it's false is when the consequent is false. Here the consequent is true, so therefore the statement is true. And again, you're not don't require you to memorize the truth tables, but you need to know where they are and how to use them. Now for number 4, they're giving you this: R, then negate S, and the caret is N, T. So we're using stuff from a previous lesson and then putting it in the conditional. And what's the next step? Well, define your phrases. We're going to say S is this, T is this, and R is this. So just convert these phrases as needed to represent that, keeping in mind that when you join these two, S and T, you're going to insert the word N. And for S, you are negating S. All right, let's see what you come up with. So looking at this, for R, they raise pigs. So if they raise pigs, we'll have a choice of C or D. These are not in the proper order. Then, that's good. That would be the arrow. And then now we're negating the S. She has a pet turtle. She does not have a pet turtle. And the caret indicates the end, and T is straightforward. He trains dogs. So if you pick C, I think you're on the beam here, so to speak. All right, let's go on. Now again, analysis of what you have. It says let P represent it is snowing outside. So I'd put a P there. And in your notes, you're going to put P equals this. Q represents the play is boring. So put a Q there. Now the statement is, if it is not snowing outside, so what are we going to do to the P? We're going to negate it. So we get negate P. Then the play is not boring. The play is boring. We're going to negate Q. Now, when you do that, it's rather easy to see how it matches up. And that matches with this last one here. So again, you're learning symbolic logic and then use of truth tables, applying symbols to statements. And that's what this section and these sections has been about. All right, let's go on. Now, example 6 may look complicated, but again, take it item by item. Now, here we're saying, let P represent a false statement. So in a sense, this is going to be false. Remember, this is an and. Let Q represent a true statement. But now we're negating a true statement, so this becomes false. So once again, Q represents a true statement. So the negation of true gives you false. So now keep this in mind, that false and false in the and caret combination is false. So we know our consequent is false. Now let's look at our antecedent here. We said R represent a true statement. So negate R, which is true, will make this false. So now we have false yields false. We said in the conditional, the only time it is false is if the consequent is false. Now, if they're both false, we say that is true. Okay. Now, I spent some time working on number 7, and we want to know whether the statement, first of all, is a constructed truth table, and identify whether this statement here is a tautology, which is something that repeats itself. Examples that I gave in our flipped classroom lesson was, I will go there myself, or let's say, I will go there personally. Well, that you will go there implies you're going to go there personally. Another example is, I will go there alone, all by myself. That would be a tautology, where you're repeating. And that's just a word was mentioned in our text, and we're using it here. So what I did is I set up my initial T-chart, and you're going to copy this into your notes. And in red is what it would normally be. But now we're going to negate the P. So by negating the P, all of these change. This is false now. This is false. This is true. This is true. Now we're going to compare F and T, which is this here, in the conditional is true. The consequent is true, so therefore it's true. Now here we have F and F. They're both false. We said in the conditional that was true. Now here they're both true. So in the conditional, that is true. Now here the antecedent is true, but the consequent is false, so this is false. So now we've got the results of what's in the parenthesis, and we're comparing it now with P. Now P is true. And this last one I'm going to change here. I changed this, thought about it again, because here we're dealing with the and. So these are both true, these are both true, these are both true, these are all true. But now this is false. False and true is false. And it looks like a tautology because normally in the and, the caret, all are false except one is true, and here we've switched it around. So that's what I'm assuming they're referring to. Let's go on. Now in number 8, we go into an old folk song. Write the negation of the statement. And here they're stating how to do it, and I've written it bigger. If I had a hammer, I'd hammer in the morning. If I had a hammer, then I'd hammer in the morning. Now we want to write the negation. So P is the statement, if I had a hammer, and Q is the statement, I'd hammer in the morning. So we're going to go, I'd hammer in the morning, if I had a hammer for P. Now, what's the word for this symbol? And now you're going to negate, I will not hammer in the morning. So let's see what you match this one up with. Something a little easier. Note that B is very similar to D, except they're using the connective or, and here they're looking for the connective and. All right, let's go on. For number 9, we're looking at the directions here. Write the following equivalent statement that does not use the if-then connective, and they're giving you the equivalency. The 3 lines here, 2 would be the equal sign, 3 lines indicate equivalency. So you're going to negate the P portion of this, and then what connective are you going to use? And the word, of course, is or, and then Q. All right, let's see what you can match up with. Now, I believe A is the correct answer, and we'll leave the figuring to you. For our last item, and this is getting a little long, we're going to take a quick look at circuits. And the key to remember, the words are parallel and series. Now, if something is in series, as we mentioned in our Flip Classroom video, all have to be closed in order for the circuit to run. So in a sense, where it's true, we would use a caret here for series. Now, parallel, if one part of it is closed, the other part is open, it will still run. So in a sense, this is the inverted caret. So this is the or, and this is the and. Now we're asked to convert this. Now notice that this part here, in order for the current to go through, both have to be closed. So this is going to be an and here. This is going to be, in order for it to go through, has to be an and there as well. But since it's in this pattern, if one side is closed, then it will go through. So the whole thing represents an or, which is the inverted. So with that in mind, that little instruction, see if you can pick one out that looks like what we've just said. And I believe C to be the best answer. There's your and there's your or, and that would be the representation of this circuit pattern in symbolic logic. All right, this ran a little bit over, but hopefully helpful, and you're going to be doing your open notes quiz.